My name's Ian Valentine. If Huawei is a smart organism, I'm some small set of neurons somewhere in the higher cortex or the central nervous system. But seriously, if you really want to know what I do, I'm a business consultant, but I have a technology background, so I'm an engineer really. I've worked in television, I've worked in aviation, I've worked in customer service, and in each of those areas I've done some inventions and done some innovation. So that's really what I enjoy doing, is taking technology to business and market problems and accelerating change in industry and in marketplaces to benefit people. The reason I joined Huawei was because I felt that I could take my talent and spread it over more opportunities. So I found my home in Huawei now. Huawei's my family. Huawei's successful not because of individuals, but because we have a formula. 99% of all Huawei companies are not Chinese companies. I work for Huawei Mauritius. It's a Mauritius company under Mauritius law, run by Mauritius people. You can't help but fall in love with the country. In terms of trialing new technology, you have everything you need. You have fast market adoption, the ability to get to critical mass quickly, an innovative population that is open to new ideas, a government and opcos that are willing to try things, and may I say it, a supplier that's willing to invest a lot in R&D and also deliver products that meet the need. These are educated people. These are people that learn fast. These are innovative people. These are people that are very proud of what they're doing. And as a result, their economy and their infrastructure is probably the most advanced in Africa. So in Mauritius, I found the combination of a peaceful, tranquil beauty and a purpose and an opportunity to really deliver value across all of Africa. In fact, the technology and the skills in Mauritius, I believe, are going to accelerate even faster ahead of the rest of Africa. But then the learning that's in Mauritius will get exported back to many of the countries in Africa as a technology incubator. Mauritius is perfect. A lot of people think of Huawei as a communications company still. But actually, Huawei is not just a communications company, it's an ICT company. In fact, computing is much a part of the Huawei product line as communications. So the next big wave that I see for Huawei is actually making a more intelligent world. And not an intelligent world that overpowers us as human beings, but an intelligent world that makes the world a better place for us as human beings. It's a joy to work for Huawei Mauritius because each one of our efforts has more impact, or more visible impact. Here in Mauritius, we're very Mauritian, and I'm proud of that.
Hello, everyone. My name is Jaya, and on behalf of IET Mauritius, I welcome you to our webinar today. Due to the unfortunate lockdown situation, we have decided to set up this event online. To kickstart our very first webinar, we have chosen the hot topic of the moment, 5G. And who better to partner with than one of the leaders in the telco industry? Our speaker today is Mr. Ian Valentine. He is a principal consultant at Huawei Technologies. Mr. Valentine has been pioneering technology innovation for the whole of his career, which spanned customer service, interactive TV, aviation, internet video, and telecommunication. He now works as a business technology consultant for Huawei Africa and has been living in Mauritius since 2018. Before we start the presentation, I will share some pointers for the audience. There is a Q&A tab at the bottom of the screen. You can use this to add your questions during the presentation. Also, our community manager, Lindsay, will add some links in the chat. Do not forget to copy them before you leave the presentation. The links are for your CPD, a diversity survey, as well as the registration link to our next event. Well, I hope you enjoy the webinar. I will now invite Mr. Valentine to share his expertise on 5G.
Thank you very much. I'm just going to share my screen here and we can start the topic. As discussed, I want to make this quite interactive. So I want to be able to answer questions as we go. So we're splitting the topic into 4 short segments, like 5G, what is it? 5G, what it is not? 5G, what it will do? And a little bit of secret sauce for the engineers at the end about the technical magic. After each one, I'm going to take questions and answers, which if you type them into the questions and answer box, I will be able to pull up, I hope, during the speech, and we'll take some of the top questions. We also are very honored to have support from the Minister for Innovation, Communications, Technology, who will be making a speech after the first segment. So without any extra delay, let's get into the first section of 5G, what is it? Now, it's very interesting to look at 5G in terms of where it's come from. If you're old enough to remember the birth of mobile communications, we all walked around with bricks sort of attached to our cars or our ears, and a ham radio specialist would be able to pick up the voices and the conversations that we were having because it was basically analog radio. So the first digital generation, or GSM, of mobile communications went secure. So now the voice was digitally encoded, which meant that if you picked it up with a ham radio, all you heard was a lot of ones and zeros, and it was very hard to listen in on conversations. So this was really the beginning of GSM. But the internet was booming then and beginning to come on, and everyone was crying out saying, can't we use data for this? Now, the data connection over first generation networks, or GSM, was really just a modem running over that bit stream. So the modem could only do 9,600 baud, believe it or not, for WAP, or as we knew it then. And so the generation 2, or G2, second generation mobile, as we heard it, used the data stream that we put into the voice and instead used it specifically for an always-on data connection. So now our phones didn't have to connect to get data, but they could always be connected. And this 2G data connection is still one of the most revolutionary things that's powered mobile applications. So an always-on data connection in your phone was incredible. That was with version G2. 3G, you've probably heard about, what came about because of the cry for faster data. And people used to say, now we're going to be able to do video, because you never could do video over those speeds before. And 3G was a revolution in terms of speed, but it was, I guess, a poor architecture. We really bolted on some faster data to 2G. It wasn't purely designed for fast data. In fact, it wasn't designed that well at all. It was really an evolution of GSM and 2G. The first real sit down to fully design a sort of next generation network was with 4G, which was called LTE because it stood for long-term evolution. And the unique thing about 4G, which has lasted us a long time and will continue to last because it was a good architecture, was everything was treated as data. And one of the big revolutions with 4G was also this concept of a single RAN, or radio access network. It meant that you could put up cells where the radios on the top of the masts could handle all the different protocols, 2G, 3G, 4G, with something called a software radio, which is a Huawei invention, and it actually helped Huawei become very strong in as a supplier, because we had the first single RAN and we could upgrade people to 4G very easily by using this software radio architecture. But the big thing about 4G was really just the fact that it was all data native. And that reflected the internet at the time, the fact that everything was going to be done over data. But the problem with 4G was really that it's a shared resource, both the spectrum, which we call the air interface, or the radio, and also the protocols. Everything about it was basically a shared resource. All types of data were treated the same. Now, as we move forward, the industry has had an opportunity to redesign mobile communications around the real applications of these mobile communications. So 5G is a really big redesign of the air interface, the core network, and all the technology, using every ounce of inventiveness and research and development that we were able to do together with many, many partners around the world. So 5G is a collaborative effort, as I will go on to explain later. But if you actually think about what is so special about 5G, I would say that it was cloud native. You see, cloud computing is the ability to have a virtual compute infrastructure, or a virtual computer in the cloud. And this is much cheaper than having like real hardware. And so one of the things that you'll see as engineers as we move forward in explaining 5G is that it really uses cloud in a very special way, which means it's very soft, it's malleable, it can be changed. We can slice it, dice it, redefine it, do anything we want with it, because it's basically cloud native. It also means it's much more economical to roll out and deploy. So these are the real 5 generations that have led us to where we are today, 5G. And it's quite incredible. When 5G was first specified, the standards bodies, which are, you know, the ITU and the GSMA and all these standards bodies sit down and they think about it. They came up with 3 major acronyms, which are really hard to understand. EMBB, URLLC, MMTC. What does it mean? What does it mean? Well, they stand for Enhanced Mobile Broadband, Ultra Reliable Low Latency Communications, and Massive Machine Type Communications. But still, what does that mean? You know, it doesn't make sense to us, does it, as normal engineers? What are we really talking about? Well, it's very simple. Very simple. Number one, enhanced mobile broadband is really all about speed. Just means faster mobile broadband. Okay, we understand it. 2, the reliable low latency communications. This is fairly new to many people, but low latency is a thing that limits the throughput. It's the amount of time it takes for a packet to get like from one end to the other end of whatever you're trying to do. And it's a fundamental limitation. If you don't have low latency, you can't get high speed, because basically there's some overheads on packets and things like that. But also there are many applications that need low latency, where there's no delay between your action and the response. Right? And then number 3, the massive machine type communications. What does that really mean? Well, that's all about how many devices you can connect. People have probably heard of the Internet of Things, right? Where everything is connected, from your smartwatch to your light switch to everything else, the cat's eyes in the road, you know, the street lamps, the bins, everything's going to get connected. They don't need enhanced mobile broadband. They don't need massive speed, but there's a huge number of these. And there was a real limitation in 4G about how many connections you could have, what the maximum speeds would be, and what the latency could be brought down to. But that's really not everything in 5G. Everything that is, you know, characterized by those 3 cover all of the spectrum of industrial applications that we might want to do. But when the specification got going and everyone started really thinking about the vision, then actually there were a lot of extra bits added in. So instead of just a triangle, we end up with a hexagon or lots of different things. And you start having requirements added in, like mobility. Okay, can my connection work if I'm on a train going at 500 kilometers per hour, right? How can I reuse the spectral efficiency? Because radio is a fundamentally limited way of communicating information, as the engineers in the room that have done communications theory will know. And of course, in this green environment, how can we get more bang for the buck in terms of network power? We don't want to be burning too much electricity to do all of this. So a lot of extra bits were added in on the sort of advanced specification of 5G, all of which is coming to pass. But let me just focus on the first 3, the number of connections. With 3G, you could maybe have hundreds of connections per cell. With 4G, a massive benefit. Now we've got densities of maybe thousands per cell, like a 10 times increase over 3G. When it comes to 5G, we're talking literally millions of potential connections, not per cell, but per square kilometer. And if you imagine from a cell, you go 500 meters in one direction, 500 meters in another direction, that's a kilometer. You make that into a square. You're not talking about a very big area, but you can have millions of connections. Now, there's a lot of things that go into being able to support this number of connections. You might think why, but there are now devices that can connect to 5G networks that have battery lives of years. So you can put a battery in something and it can connect to a 5G network, keep its session open, remain connected for years before you even replace the battery. So this is an actual fantastic leap in capability, just in the number of connections. I want to put the rest of the main three into context for you. So let's think about latency a little bit. In 3G, we talked about latency in terms of hundreds of milliseconds, which is actually very poor for a network. If you had 100 millisecond latency on your network in your office, you'd be saying, oh, this isn't a very good network. With 4G, it began to become acceptable in tens of milliseconds. So what's the target for 5G latency, and what can we do with that? 1 millisecond latency. Now, this is faster than I get off my fiber connection between my house and Port Louis, down glass. So it's an incredible benefit, latency reduction. But, you know, latency is not something that consumers understand. So I want to put this into a bit of context. With 4G latency, how far would a car typically travel between the time you send a request out and get the answer? Well, it could be 1.4 meters, typical car speeds. So think about that. The car has moved nearly 1.5 meters in the time it takes you to get a packet round trip. Now let's look at 5G. How far will the car have moved in the same packet round trip time? Well, can anyone guess? 2.8 centimeters. Now let that sink in for a little while in terms of decision making and awareness of where the car is. If a car sends out its position and says, I'm here, by the time the packet even gets to the network and is acknowledged, it's not there anymore, right? It's 2 meters in a different direction. With 5G, it can be 2 centimeters in a different direction. So this is really what latency can mean. One of the things latency can mean. Now let's just put speed into the context. Most people watch video over broadband networks, and we can think in terms of how long does it take to download an 8 gigabyte HD movie, right? With 3G, which was designed for video, remember, 70 minutes to download that video. With 4G, it's much better, and Netflix and all these other things have really come of age because of 4G. Just 7 minutes, and you've got basically the whole movie there if you get the right bandwidth out of 4G, which isn't always the case. With 5G, you could get that movie in just 6 seconds. Just let that sink in a little bit. An 8 gigabyte movie delivered to you in 6 seconds. Now, what does this do? I mean, this kind of capability opens up a whole range of new capabilities. With 3G, you can think, now I can access my health records, right? With 4G, you can say, now I can have a video call with my doctor, and I can talk to him on a video link, which might make remote consultations really useful. With 5G, we could talk about doing interactive remote brain surgery or brain imaging even, where someone could be controlling an imaging machine remotely, and there'd be no lag between where he wants to point the machine or his tools and the actual tool itself. Absolutely incredible. And this opens up many, many more application areas. So let's go back to first principles in physics a little bit. How can you possibly get these kind of performances? Well, those of you in the room that have studied communications theory know that the information that you can carry on a radio wave is basically proportional to its frequency. So 5G has had to increase the frequencies that are used to higher frequencies. We'll talk about this a bit later on. So where does it go? Where does it go? And higher frequencies have different characteristics, like they don't go through walls very well. They maybe don't go as far, but they also have benefits like you can beam them better and many other things. There's a trade-off, obviously, between using lower frequencies, the traditional frequencies, and higher frequencies, which get you the higher throughput and the lower latencies. So with 5G, we're going up into the gigahertz band, 30 gigahertz, into the millimeter wave band, and even up to 100 gigahertz. So this is really cool. The fact that we can use this whole range of frequencies for 5G. So implementing 5G does involve new spectrum being allocated above and beyond, but it doesn't need that, because 5G will also work on the spectrum that has been allocated to 2G, 3G, and 4G, the traditional sort of single-digit gigahertz spectrums. So one of the big things that I need to explain about 5G is the fact there's a whole new radio interface, and I'll spend time on that later, try to simplify it for you. But that's not all. 5G is also an architecture. Now, I spoke about it being cloud native earlier on. And this is core to the way, core, literally, that's funny if you're an engineer like me, but the core, we call the network core, the core network is the backbone network, right? And the backbone network for 5G is something that is as important to the performance of 5G and the applications that it's used for as the radio interface. So you're going to hear me talk a little bit about the air interface or the radio interface or new radio, but you also hear me talking about the 5G core, which is the backbone, which is actually distributed and virtualized like a cloud. And it even means that, as I'll come on to at the end, that you can have like network edge computing with a whole range of opportunities there. So 5G is made up of a lot of things and has a lot of capabilities. The key bit being the new radio, the second key bit being the 5G cloud-based core network. And I'll talk about how we implement those in a future segment. But in this introduction, it wouldn't be complete without thinking about what scenarios do we use for each of these three core characteristics: the speed, the low latency, and the massive communications. So let's start at the bottom and talk about Internet of Things and massive machine-to-machine type communications. What's going to get connected with this massive connectivity capability? Well, our smart home devices, our energy and utilities. Like when you have a water pipe, it should really have a sensor in it that detects flow. And if you can measure flow, then we can find leaks. Same with electricity, same with anything that we engineer. They can now be instrumented so we can measure the performance of those systems, and we can monitor and repair those systems, maybe even proactively. Agriculture is the same. You know, if you want plants to grow properly, you have to manage nutrients. Maybe you want to have sensors in the soil that automatically give the right amount of water to plants. Maybe one use case I heard really good was a health monitor for a cow that tells the farmer exactly what's going on for the cow, which is very good for getting milk and being able to look after the cow's health. Logistics is another massive area, and obviously smart city. These are just some of the applications of the high connectivity that 5G can bring. When you talk about low latency, I've talked a little bit about AR and VR a little bit, but industrial automation, being able to have robots in factories actually managed by 5G connections inside buildings, having remote surgery where you're basically your hands, you know, when you move your mouse, you don't think about moving the mouse up or down. This is the way a surgeon works when he's working with some of the tools. And because he can look really closely and manipulate very small tools, even if you're not remote, having low latency communications between the actual tools that you're using and the actual knives or surgery that's going on is it gives the doctors superpowers in order to be able to do very delicate surgery. Obviously, self-driving vehicles we've talked about, and applications like the smart grid that just mustn't go down. When you look at the speed part of it, the enhanced broadband, it's mind-boggling what we might be seeing soon. Cloud gaming obviously is something that everyone's interested in. AR and VR, where you stream video from the edge and overlay it with the position of your head, giving you information about what you're looking at, being able to do more than 4K video, all sorts of applications for that, even in-car entertainment. So in this introduction, I've given you a quick idea about what 5G is capable of and what the characteristics of 5G is and how we got there. I'd now like to see if I can pull up the Q&A options and see if we've got some nice questions which have been upvoted. So will 5G require millions of cells? Got 3 upvotes. That's a good one. Millions of cells. Yes, of course, around the world, it will have millions of cells. But I think people are worried about the number of cells because they think every cell is going to look like one of these towers. That's just not the case. 5G is much more like Wi-Fi. You know, when in the millimeter ranges. When you walk into a hotel or a lobby, you don't notice where the Wi-Fi antennas are, and small microcells will be necessary for some of the 5G coverage, but they won't be a problem because they'll be built into streetlights, they'll be built into power sockets, they'll be built into other appliances. And as I'll show you on the roadmaps later on, that's not the first thing that gets rolled out in 5G. So yes, there will be more cells, and the handover between cells is very, very smooth and very wonderful. Let's try and get through as many of these questions. Will 5G change the current wireline architecture used for 4G backhaul? Yes, kind of. Like later on I'll talk about the hybrid deployment options where you can have the 5G air interface to give you more spectral capacity at the cell and still use the same backhaul if the same backhaul is fast enough. A lot of the cells are fiber backhauled, some of them are microwave backhauled. But yes, upgrading backhauls is going to be part of the upgrade if we do that. What's the relationship between 5G and Wi-Fi? Very, very good question, this one. Very good question. Everyone thinks Wi-Fi sucks a little bit inside, and certainly when you have 5G, you know, you're saying my Wi-Fi is not good enough anymore. But actually, much of the technology that's been developed in 5G has come forward into what we call 4.5G, and also something called Wi-Fi 6. So when I talk about beamforming and some of the other slicing mechanisms that is in 5G technology, they are now working their way into the next standards of Wi-Fi. So although Wi-Fi is not part of the 5G specification, the technologies that have been developed for 5G will in fact make Wi-Fi better. Maybe we've got one room, it's another backhaul. Does 5G affect the backhaul network? Yes, think of answer that. Is massive MIMO mandatory for 5G deployment? Interestingly enough, massive MIMO is already being deployed as 4.5G. I'll talk about that later. Yes, it's part of the core capabilities of 5G, and it's a good thing. I'll show you later. So I think that's some of the very, very good questions there from segment one. Because we've done an intro, and we did at Huawei, we did a lot of government training recently of officials in Mauritius. We've got good support from the Ministry of Information Technology, Communications and Innovation. In fact, the minister has actually recorded a speech. So if we'd like to jump over to the other PC, I think it's time to just listen to our minister here in Mauritius and what he thinks about 5G before we go on to the next three segments. So can we swap computer screens and we will play this.
Members of the Institute of Engineering and Technology, representatives of Huawei Technologies, industry partners, technologists, IT experts, engineers, dear friends, ladies and gentlemen, good evening. I am pleased to meet you online today as our country is on its second confinement due to the COVID-19 pandemic. Thanks to high-quality internet, we can connect with each other in a safe and secured way. Driving connectivity in a country has always been a priority in Mauritius and for the government, starting with 1G in the early 90s to 4G deployment in the past decade. Our telecommunication operators have been in the forefront of technological evolutions, bringing increased bandwidth, coverage, and quality of service in the provision of mobile and internet technologies. Today, we have increasing consumer demand for connectivity, especially in these COVID times. We study, work, and spend leisure time on e-learning platforms, application software, social media, and gaming platform, relying on the strength of the underlying connectivity backbone. Today, Mauritius is covered by fiber to the home, whilst we also have a full mobile coverage running on 3G and 4G networks. Surprisingly, as it may seem, mobile penetration stands at 150%, made up mostly of smartphone users. Broadband internet connectivity comes to 92%. This is a strong foundation for supporting work from home activities. Following the onset on the second lockdown, enterprises switched naturally to work from home. The reflex has set in with the experience of the first lockdown, where businesses overnight transited from work to home and set up e-commerce platforms for a seamless continuity of their selling operations. Nowadays, they rely more and more on the internet infrastructure to source their raw materials, goods, and other services. Our youth expand their understanding on topics through e-learning sites here in Mauritius and across the globe. International connectivity is becoming more vibrant with the soon to be operational Métis cable, which joins the already set up SAFE and Lion/Lion 2 cables. Seeing the growth of international bandwidth, Mauritius is readying itself for welcoming a fourth cable in the horizon of 2022-2023. 5G is a key technology of 4IR, the fourth industrial revolution. It will definitely bring efficiency to our industries with services, and it will change the way we live, we work, and we entertain. Innovative technology will also be an innovation platform and an opportunity for a series of new industry sectors like rail, like health, or energy. The country's mobile network are going for a major boost with the expected coming in place of the 5G technology. Local telecommunication operators are working on the deployment of 5G on the island. We need to keep embracing new technologies and guarantee an open communications and computing infrastructure to allow such specialized services and innovation to flourish. At the occasion of IET monthly talk, I wish that today you make the most of this exposure on 5G as a new technology to transform every industry, thus bringing more value to the digital transformation of the economy. Communications is not complete without computing, and 5G will bring the benefit of the cloud all the way to the edge of the network. With 5G technology, the cloud will not be something you just connect to, but will become the intelligent system of the Mauritius digital society and economy in every device and everyone's pocket. Progress demands that we do not stand still. This technology is spreading rapidly across the world. We are not going to be the first in 5G, but in Africa, we might stand to the benefit the most. The communication infrastructure of Mauritius will not be just about communication. It will be about intelligence, and intelligence comes from our people. I'm glad to see partners and stakeholders investing in people through the innovative programs, even during this period of confinement, during the lockdown, drive innovation and contribute in the ICT talent ecosystem in Mauritius. Thank you.
Good. Let me just try and share my screen again. Okay, I hope everyone can hear me. I'm sharing my screen again. I just want to check that I'm not muted. No, that's fine. Should be fine. Okay, thank you. That was really good from the Minister. While he was speaking, I got a chance to see the chat. There was lots of extra questions in the chat. So if you put your questions in the questions and answer box, not the chat, I'll see them better. Some good questions in there, though, much of which I think I will cover in the next segments, like, you know, is it just hype, and is it just a commercial game, or are handsets available? This segment's a bit more light. So I want to talk to you about 5G, what it's not, because there are lots of myths, things about 5G, and I need to dispel some of these things. So working for Huawei, I think one of the things that I have to dispel quite often is 5G is not a Chinese invention. You know, it's like, this is really funny, because people think, oh, well, 5G. No, there are 5G suppliers from Europe. America's a bit behind, but certainly Huawei is not the only supplier of 5G, and we're not the inventors of 5G, although we have done a lot of research and development. It's worth thinking about actually how far back 5G went. So the standards bodies started talking about the need for 5G nearly 8 years ago. And it came in multiple releases, release 15, 16, 17 is going on. And some of the earlier releases of 5G were not really marketed as 5G. They came out as part of 4.5G, or so, an enhancement to 4G. So some of the early stuff, especially around enhanced speeds, were brought forward and released as part of the sort of 4.5G area. So 5G isn't so much a big, you know, it's already there in many cases. It's certainly not a Chinese invention. Huawei is involved in a lot of these standards bodies, and we've contributed a lot of R&D. We've contributed a lot of ideas, but this goes back to even our single RAN idea with 4G. So it's a global initiative. 5G is a standard that's been set by the standards bodies throughout the world, with industry participation from all stakeholders involved, both telecommunications companies, hardware providers, industry stakeholders, and it's been done in a participative way. So it's just a beautiful example of the world working together. One of the other things that comes up a little bit for myths that maybe needs to be busted is 5G. Is it a security risk? I mean, is it a security risk? You hear people talking about this. Actually, it's much less of a security risk than 4G. Imagine where all the data's on the same network, and that network is vulnerable. Maybe somehow it's you capture data somehow, and you begin to decode it, decrypt it, you begin to look at it. On a shared network, it's much more vulnerable, because you've only got to sort of have a vulnerability in that one part. With 5G, because of the segmentation and the cloud architecture, the network slicing, the mobile edge computing, and all the other things, then it's much harder to gain access to the whole picture of what's going on a 5G network. So 5G is inherently more secure than 4G. And in fact, all these clouds, all these bubbles underneath, the malware analysis, the accounting, the digital forensics, the cross-layer security, the intrusion detection and prevention mechanisms, security analytics, physical layer security, these are all things that have been discussed in the standards groups to make 5G more secure. Obviously, if you're doing brain surgery, you don't want someone suddenly taking over the controls, right? So all of these applications require end-to-end security. And security must always be viewed in that sense at the application level. The most vulnerable data we have is our application data. So when you look at even vendors and infrastructure, you have the layer of the hardware or the computer. Then you have the kind of operating system that's like Windows or Mac OS or Android on your phone. And then you've got applications above that. So the most security risk is in applications. It's not in the network technology itself, and certainly not in the hardware or the low-level radio analysis. And Huawei's role in this is as a supplier of hardware and technology. The operator is really like Mauritius Telecom or MTEL. They're like the OS. So the operator, the operating system of a computer will know what you're doing, but not necessarily have access to the data inside the apps. And actually the security should really be addressed in the application layer in what you're actually doing. And 5G does that as well because of the segmentation of different applications into different slices. So actually it's more secure than 4G. And in fact, it's had security designed into it from the beginning. So 5G is not a Chinese invention. 5G is not a security risk. Okay, maybe it's a health risk. I'm scared. Maybe, you know, you see this stuff on the internet about 5G cells and people getting, I don't know, boils on their nose, which they get anyway, and then suddenly saying, I walked near a cell tower and I got a boil on my nose. There must be a cause and effect there. No, just coincidence. But let's think about this from a pure physics point of view again. And the best way to understand this is in terms of what is radiation. People think, oh, electromagnetic radiation, radiation's bad. No, light is radiation. The heat from your fire is radiation. So you have to understand the frequencies involved. There is a thing from nuclear power stations and from the sun and gamma rays, cosmic radiation is very high frequency and damaging. This could be electromagnetic or particles that can hit you from radioactive decay. That's not what we're talking about here when we're talking about radio waves. In fact, the energy of a radio wave to do anything to your skin, to anything, is proportional to its frequency. So where in 5G in the spectrum does 5G sit? Well, you'd be very surprised to understand that 5G, all the radio frequencies you could ever talk about, even the microwaves and the millimeter waves, they're all way, 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 way longer wavelengths than visible light. So at the same power, if you're not scared of a light bulb above your head, which is a much higher frequency than radio, you shouldn't be scared of anything that's of lower frequencies, because just by the laws of physics, just the way they can't carry as much information, they can't carry as much energy, they can't do anything. So really, the reason we use light down fiber optic cables is because it's a higher wavelength than radio. Radio we have to do a lot of engineering to get the same throughput of data through radio as we do through light. It'd be much better if we could just have laser beams, you know, connecting our phones to the cells. That would be really cool. That's what some satellites are doing now for broadband. So no, radio at these powers can't do it. Lots of things about this I could talk about. I know we're short for time, but you know, your phone itself is transmitting to the tower and the tower is transmitting to you. When the tower transmits, the power goes down in a square of the distance from it. So by the time the radio waves from the cell reach you, they've gone down a square in power for every meter distant. So it's more likely that your phone is more powerful at the point you're at than the mast itself. So the power doesn't do anything. Also, the power from the cell is very much more efficiently used, so it doesn't broadcast everywhere. So the 5G cells will allocate the power, so I'll talk about it later, to where the devices are. So yeah, the laws of physics basically eliminate 5G as being a health risk. Some people would say, but what about microwave ovens? Don't they work at the same frequencies? Yeah, they do, but a much higher frequency. And the only reason microwave ovens do anything is because 2.4 gigahertz is the resonance frequency of a water molecule. So if you don't have water in your food, the microwave oven doesn't warm the food up. So you're shaking water molecules with high power 2.4 gigahertz radio waves inside a microwave, but they're much higher power than anything you get off your phone or your cell. So they haven't got the energy to even shake a water molecule, and you don't feel any heat from your phone in terms of microwaves. So no, 5G is not a health risk. 5G, it's not an option. Now, I think one of the chat questions sort of asked about this, isn't 5G just another bit of commercial hype? Why do we actually need it? Well, another way to address the need for 5G is to look at traffic growth on our networks, and traffic growth is going up exponentially. There are a lot of drivers for this. Video is one of them, but other new applications go up. Now, when you deploy 5G, there was another question in the chat about cost. What does it cost to update to 4 to 5G? Well, if you look at the costs in terms of the performance, 5G is so much more economical to roll out to get extra capacity than 4G. In other words, let me put it a different way. If we were to try to upgrade our 4G networks to have the capacity we know we're going to need, we would have to spend so much more money than if we just switched to 5G. So switching to 5G with its efficiencies gives us much more growth for the money. And so actually it's a cost saving typically, compared with growing a 4G network. And this is why its adoption rate is faster than 4G. 5G is getting adopted globally faster than 4G. Why? Because it gives the operators an opportunity to grow their capacity with less investment rather than more. If they stuck with 4G, they'd be spending more to get the same capacity increase. So is 5G hard to implement? Is it difficult to implement? And it's a bit of a complex slide here, but it's really in two parts. You have to look at the cell and then the architecture. So on the cell side, can we just like put up a new antenna, swap a bit of antenna and reuse the rest of the cell? That would be really cool if you could just like swap one of the antennas and just swap a board in the cell and you're at 5G. Well, let me tell you, for the existing frequencies in many of the Huawei 4G cells, it's even easier than that. There's certain parts of the 5G spectrum where we're reusing the 5G architecture, where we're reusing the 4G spectrum, where because of our software radios, we can actually upgrade the cell with software. And let that sink in a little bit. Because the antennas that we deployed in 4G were soft, we can reprogram them in software to work with the 5G protocols. They won't have all the effects, all the benefits of it, but some upgrades to 5Gs in some cells can be done with software. Other ones, swap the antenna, swap a board. But really, when you get to the architecture, there are two ways to evolve a network from 4G to 5G. There's a so-called standalone model, which means you take the core, you take the air interface, you put it together, it's 5G end-to-end. It's kind of like a new option. This is what you call like new radio and the next generation core. So this could be the top route on my little decision tree. This would be like a new build, a greenfield site, or someone wanting to roll out 5G with a new core and new cells. But you don't have to do that. You can actually put the new core in and mix the 4G and 5G radio architecture together at the same time. So you could use 5G for the bits it's good for, like the massive connectivity for IET, and still keep 4G for data. And you can go the other way around. You can not implement the core, so you can have the existing packet core and then still have your radio options. So this actually gives you a matrix of, do I go standalone? Do I have the enhanced packet core, the 5G core, or do I go with the new radio or combine new radio, old radio? So there are many different ways to evolve the infrastructure into 5G. So myth number, lost count, 5G is not hard to implement. So that's a little bit of myth busting about what 5G is not. Let's see if that generated some questions. About 14 questions. Let's see which ones are upvoted the most. Will 5G lower broadband costs for the general public internet user compared with older technology, or is the technology? Yes. So basically what's happening in every network is people spend a certain amount for mobile communications, but always want more. So 5G allows the operator to give you more for less. You probably end up spending similar amounts, so it doesn't cost the public more, but there's just increase in value and capacity that you'll get. Now, there may be some vertical services where there might be a premium. So if you want your slice to be just for you, like for the police, then that might be a premium, a new application area. What about cost implications for the service, monthly subscriptions and new devices? Are they readily available? Yes, 5G devices are already available. 5G handsets, you can already buy them in Mauritius. IoT devices are coming along. There are many protocols for that. Let's look at so cost implementation for the general public internet compared with older technology. No, it's not for corporates only. This is both for vertical industries and mass market adoption. What about the cost implication for the service monthly subscription device? Oh, the minister mentioned the changing. Minister mentioned new industry revolution with 5G. Can you elaborate scenarios for Mauritius? Yes, I've got a segment on that coming up, which I hope to focus on Mauritius. How can the country benefit and thrive with the new radio and 5G? Yeah, the new industrial revolution and 5G. You know, Mauritius is an advanced African economy that is rapidly getting digitized. And the value in terms of connectivity to GDP has been proved economically. So this is what's funded any form of broadband development, is that the more connected we are, there's a correlation between that and GDP. So as we get more connectivity and more capability out of our connectivity, it has a direct impact on GDP. Now, there's many, many things that build that relationship, but at the macro level, greater connectivity equals greater GDP. Is there a new question? How to identify 5G compatible devices? I think it's sort of stamped on the box. You know, just check the label. Okay, let's get back and jump into the next question, because this follows on from one of those. What will 5G do? And particularly, maybe, what will 5G do in Mauritius? Now, the first thing is, there's a whole bunch of stuff, right? But it's an evolution. So with 3G and 4G, we've seen a new range of applications. And as we go into 5G, there's again a new range of applications. I think the thing to take away here is that they're new. Applications that you'll see for 5G, it'll do everything that 4G does, but better. And on top of that, you'll have things like things that you don't even see, like your car being aware of congestion, or even the position of other cars, or the intention of another car around about, or things going on inside your smart grid that, you know, like the power not going out because, you know, we know when transformers are going to fail. The port in Mauritius having more throughput because we can actually automate the workflows between, you know, remote controlled cranes and unloading and loading of containers, better quality food, many applications. Let me try and go into some of these, because they won't all happen straight away. So 5G, all those, one of the things I meant to say is, out of those three things, the fast speeds, the massive connectivity, and the low latency, sounds like a wonderful thing. I've got to let you down here. You can't have all three at the same time, right? This is why the slicing comes in. See, you don't have 1 million connections in a cell and give each one of them, you know, more than a gigabit per second constant always on throughput. No. Each device needs a different combination of these features, which is why 5G is much more industrial. It has much more vertical applications, which keeps the consumer price low, because the carriers can then charge a premium for some of these business-focused services they can roll out, which they couldn't really do with 4G. So there's a phased evolution of the combination of this. The first application really, which we're seeing now, is where 5G is replacing fiber to the home. We call it fixed wireless access, where actually it's so good in forming this beam between the cell and the home. It's like having a fiber in the sky, and you can put a bit of CPE, or customer premise equipment, in your house, and it's like having really reliable, not like 4G style, but, you know, really reliable connectivity to the house, and fast as well. So fixed wireless access with TV is really happening right now across many countries in Africa, in fact. And we're seeing augmented reality and virtual reality live events happening, where we're actually, this is more to do with the uplink, that 5G has really good uplinks, so we can go out live, we can put cameras in different places, and we can then experience that using the network as if we were there, because the uplinks in the different cameras can all be done, and the end-to-end throughput. The second phase is much more about taking those characteristics and building verticals around it. So being able to do cloud gaming and sort of high resolution surveillance. Like, it's very important for surveillance cameras to be able to see further, and if they can't see further if you keep the resolution low. So an SD camera might be able to only pick out someone's face of the villain that came down your drive, you know, if he's up close to the camera. But with an 8K camera, you'll be able to zoom in, and you'll be able to see if he shaved that day. So that's the benefit of some of this, you know, high resolution surveillance. The third phase is where we really move into the latency and the massive IoT connections. So you're beginning to see things like, you'll be able to have holographic concerts where people just appear on stage and can interact with people in the audience, meetings which are much better than Zoom, where the speech is getting translated in real time with the cloud, and people's faces are replaced with avatars with the lip sync to the new language, like on Star Trek, where you have a universal translator. Many other things going through as we move forward. One of the big ones is connected vehicles, and I think this is really important for Mauritius. If you imagine the policemen on the roundabouts, they're using their brains as much as they can. They're kind of on the radio trying to get the throughput of the roundabout working in rush hour. But actually, we have things in other countries called smart motorways, smart junctions, where they are looking at traffic patterns way further out and clearing roads ahead of things. So rerouting traffic, making sure that the traffic throughput of any junction or any area is really efficient. Also for parking, being able to just drive into a multi-story car park and find parking. Platooning increases the capacity of the roads, because the lorries can act like trains. There's one driver in the front lorry and all the other drivers are just automated following the front lorry. They act like trains on the road. Now, especially good for long motorways, which we don't have so much in Mauritius. But the traffic on demand capabilities will definitely help Mauritius in terms of traffic throughput. Much cheaper to roll that out at a smart junction than build the new, fluid flow junctions. I know we are building fluid flow junctions, like between Port Louis and Eben at the moment is a good example of that. Self-driving cars will definitely be there, so you can make money out of your car. It can go out and earn money for you, being a taxi, and vehicle to everything communication. So everything's going to get smarter. One of the things about this smart society and the connectivity is, I don't know if you've seen these bikes. They're in London, China, New York, everything. They don't need charging stations anymore. They kind of charge up on their own. They don't take much power. They've got GPSs involved. You can just leave a bike where you finished it, and then the app that you want to hire a bike from, will just tell you where the nearest bike is, and you don't need bike stands. You can just share bikes through a sort of shared community. People are rolling out new businesses like this. Obviously, metering and parking I've mentioned already. There's a whole world of it. I wish I had more time to go into some of these benefits of smart IoT connections at large scale. But basically, let me just summarize that. The more data you have, the more intelligence you can build into the network, and you don't get data without sensors. So having sensors feeding large data lakes in the cloud allows intelligence to be layered on top of that, which can really reduce the cost of maintenance and the efficiency of the whole of society. In fact, there are many, many things in this. I wish I had more time here. I think the one I really want to focus on is green energy. Reducing carbon emissions, reducing travel, increasing energy distribution, and utilizing scarce resources are all going to be big benefits of 5G. It's just fundamental the way this is going to change society. Let's see if we've got some more questions, because we must keep this interactive. Let's see if we've got some new updated questions, or if it's the old ones. How far are the 4G network operators in Mauritius equipped to implement 5G as a soft option without any hardware upgrades? Yes, that's a very good question. So Huawei does most of the 4G in Mauritius, and the software upgrades to the cells should be fairly widespread. I think probably Mauritius is in a better place than most countries. I'm not familiar with the per cell architecture of the operators here, but generally speaking, Mauritius should be in a good situation. But I think the operators here want to do more with it. I think they will go with using more spectrum, and that will mean that, and some of the more advanced capabilities. So the software upgrade gets you onto the 5G protocols, but it doesn't give you everything that you get from the whole 5G spec. How to identify 5G compatible devices? Old question. We need more questions. How much about power requirements for 5G site compared with 4G? Very good question. Yeah, very good question. So does a 5G cell use more power than a 4G cell? The answer is a little bit more, like 15 20% more, maybe. But what you get for that in terms of throughput is dramatically more than you spend on energy. So in terms of cell efficiency, it's much, much better, as I mentioned. But actually, the cells themselves are becoming much more resilient. So cells now can be run pretty much off solar and lithium. You can have a solar panel farm around a cell, charge up batteries, and you can do a good job. Certainly, some of the small cells could use some channels for backhaul and be solar powered and then act as microcells. So there's a lot going on power efficiency. Let's see if there's another one been uploaded here. 5G is energy intensive. Lots of cell sites with high energy consumption, higher than legacy 2G, 4G. Are ecological aspects considered? What is being done to mitigate this with global warming? Yeah, absolutely. It's not the right question, because just because 5G is not energy intensive, right? It just uses a little more power, but you get much more for that. So actually, it's greener than 4G. When you think about it, it's a much greener option than 4G. So there's a bit of a false premise there that it's energy intensive. It's not really. It's much more efficient than that. As technology evolves, we're scrapping the old equipment, installing new infrastructure. By equipment, do you mean some of the boards in the base station, some of the cloud infrastructure? Most people don't understand that carriers are constantly upgrading and adding new capacity. So, when you move a core router from, it becomes a capacity bottleneck. Invisibly, they'll take that out, and the interface cards will move from, say, 100 gigabits to 1,000 gigabits throughput, and they'll do these maintenance and swapping. So this is going on all the time that people are upgrading infrastructure. Okay, let's try and keep on track with the time. So good questions, everyone. Keep them coming, and make sure you upvote them. In the last segment, we're going to talk a bit about some of the technical magic. So I think you're all engineers and will appreciate some of the design principles in this. So let's answer this in 3 sections. How can new radio do so much, right? Because the laws of physics say radio can only do so much. Like if you have a walkie-talkie, only one person can talk at a time. That's not very good. So, how do we get around all the limitations of fundamental radio, and what's happening in the 5G core and power and efficiency we'll talk about. So I want to talk to you a little bit about how new radio does so much. So we talked a bit about MIMO. I want to talk about massive MIMO and then talk about massive MIMO in 3D. So let me think about this from a spectral efficiency point of view. You imagine a cell, be it big or small, having a limited spectrum. So if it's transmitting on a frequency, then you can't reuse that frequency. That's used for one thing at a time. Now imagine the cell is split up into segments, like a pizza is divided up, and you can begin to transmit in this direction on the same frequency as you're transmitting in this direction, but they don't interfere. There's no interference anymore because they're different directions. So now you've got a 2 times gain. Now imagine that 4 times, now 8 times, now 16 times, right? So then you can get up to 64 transmit, 64 receive in terms of pulling channels together and also beamforming. But now I want to take it a step further. Imagine that pizza which is round has a horizontal direction, right? But actually now imagine that you can do it spatially in 3 dimensions. So you can begin to get your beamforming such that you're spotting people, go over someone's head, if you like. I'm gonna talk to this guy behind the other guy using the same frequency, right? All these things add together. You get bigger arrays, like more actual radios in the antenna. So you get this array gain. Then you get this gain from beamforming, right? Reusing the same radio spectrum, from a law of physics point of view, multiple times at the same time in different directions, in different spatial directions. There's also a thing called the multiplexing gain, which is actually each one of these things that you think can only do one thing is probably doing 16 things, right? So multiplexing stuff into the same radio. And then there's the diversity gain. Actually being able to have the different cells in different places gives you inherently more capacity as well. And 5G allows you to hand off between that, because there's a separation of the data plane and the control planes. And another part of the separation is separation of the uplink and downlink. So this makes it really important as well, is that the cell could get to you at times where you on the same frequency couldn't get to the cell because your phone just can't get back to where the cell is, but the cell can get to you. This means that you can have a downlink on one frequency and an uplink on another frequency, and 5G will allow that whole thing to work seamlessly. So it can pick the right bit of spectrum to reach that person at the same time. So there's lots of magic in the radio interface, which is just achieving incredible capacity, even changing the size of the segmentation, the bands, the packets can be dynamic and intelligent, which means you're using the spectrum more efficiently. So there's huge smarts. It's very clever stuff in the new radio. The core. Okay, yeah, let's talk a bit about some of the magic that's going on in the core. I need to introduce two terms to you. One is network feature virtualization. The other one's software-defined networks. Don't get scared, right? Everyone's using this sort of stuff all the day. But in the old days, you'd have a physical router that would be plugged in, maybe even with cables and stuff, and that's a critical piece of infrastructure. In 5G and cloud architecture, that router really doesn't exist physically. There's a piece of software that is running on a cloud infrastructure, which means industry standard blades and stuff like that in the cloud, but the function of the router, the feature of the router itself, or the network feature, is actually encapsulated in a virtual machine. So instead of having this physical hardware anymore, it's not there. What you end up with is a software-defined network where actually the networks are not physically cables anymore. They're a logical layer above this. Now, this is all running on a cloud operating system, which is why Huawei's become very strong in our public cloud. We've got fantastic cloud technology because we can't build 5G without fantastic cloud technology. Each of the physical components and the network slices are basically virtualized on top of commodity, pretty much standard data center architectures in terms of stuff, which also means that you can be upgrading the efficiency of your air conditioning, your power, your blades, and the data center, and the network definition, which is soft, stays the same. So this is really part of the way the 5G core works. And the reason for this, when you put these two ideas together, is this idea I've alluded to about network slicing and being able to create virtual networks within the network for different applications. So if you look at the sort of needs for the industry and the services on the left, you need to package up these features for IoT differently than you package up features for something that needs real-time responsiveness. Package up differently for video, which is completely different in terms of its needs than sort of remote control applications. So each one of these different applications can then have the right slice, and it can be given and sold to the market with a service level. So you can now, the telcos can offer a premium, for example, to specialist industries for some services. Consumers won't buy them, but it'll pay for the infrastructure a lot, which brings down the consumer prices for 5G. So this idea of a 5G core is kind of fundamental to get the end-to-end benefits of 5G really rolled out commercially. So it's really cool. People were asking a bit about power and efficiency. Let me just tell you a little bit about how you can achieve that. People in the room know about binary, right? Something's either it's either a 1 or a 0, right? So this gives you, for any particular state, which takes time to transmit, right? You've got to transmit a bit. It can be a 1 or a 0. Supposing I told you it can't be, it can be more than a 1 or a 0. It can be like, supposing you just make a halfway point. Now you've got in one thing that would have taken you a bit, that can be a 0 or a 1, right? Which is 2 values. Now it can be 4 values in the same bit. Maybe we can encode it even more. Maybe we can have multiple different values encoded in the same kind of transmission unit. And one of the things that 5G does is it changes this modulation. 4G is 64 crap, and 5G 4 times better. So this is one of the things that just gives you, got the same spectrum, the same power, the same radio transmission, 4 times the data. another thing I want to talk about power and efficiency is that when you roll any of these applications out, it takes power all the way through the network, right? Comes all the way back to the data center, maybe it's the other side of the world, comes back again. Someone's paying for that. Many applications now need what's called mobile edge computing. One of the benefits of this cloud architecture, I mean, cloud, when you have a machine that is running in the cloud, you don't really care where it is. And the minister said this, with 5G, the cloud comes right to the edge. He said, even in your pocket. I thought that was beautiful, like having the cloud in your pocket. But many applications would benefit from being able to run a third-party piece of code actually in the cell. Okay, so the cell becomes part of the data center. So if you've got things that need the low latency and you've got 1 millisecond low latency on the 5G new radio, but then it takes you 10 milliseconds to go back to the data center in Port Louis and back again. Actually, you can't change that. So you want to move the code out of the data center in Port Louis and put it in the cell itself. So you can get distributed applications that take mobile edge computing to actually make the benefit of all of this. And that is more power efficient and more efficient on compute resource and everything to get a better distribution of the compute. Gosh, I don't know how we're doing for time. I think basically we're on time. I'm very strict on my timekeeping. Let the revolution begin. Let's look at some questions and then we'll close out the seminar. Let's have a look at this. Open questions. Can we go directly to pure 5G with network slicing, or shall we go stepwise through the NSA mode? What do you advise? Okay, so that it really depends on the project planning for the operator. Of course, you want to move to 5G end-to-end. There are ways to do some degree of network slicing on the older cores. So certain verticalized services could be sort of manually set up to support verticals. I think the way things happen behind the scenes for the operators is really evolution, not revolution. So there's ongoing changes. But going directly big bang, that's not really the way you build these things. The minister mentioned industrial revolution. Can you elaborate on scenarios for Mauritius? I think we've done that. Is that the only new question? Will 5G lower the broadband cost for general public? Yeah, I think we've done all this. So we got one new question out of that one. Okay, that's good. So, you know, that's been a bit of a marathon. I hope it's been very useful. We've done the questions and answers for section 4. My name's Ian Valentine. I work with Huawei as a business consultant. So I love this stuff and I love helping Mauritius. Our motto in Mauritius is in Mauritius, for Mauritius. If you want to follow me on social media, you can get all my social connections at ianjvalentine.com or email me at Huawei. So it's ian.valentine@huawei.com. With that, I'd like to hand back to the IET for the closing remarks. Thank you very much.
Thank you, Ian. So on behalf of IET Mauritius, I thank the speaker, Mr. Valentine, and Huawei Technologies for their amazing presentation on 5G. Many thanks to the audience as well for attending the webinar. I hope you enjoyed it. We would also like to thank the Minister of ICT and Innovation for taking the time to share his insight on the topic. And we are especially grateful to our IT community manager, Lindsay, who set up this Zoom presentation for us today. Thank you, everyone, and have a nice evening.
Thank you.
Bye-bye.